Hello students, welcome to class 11 physics class. Today we start the next new topic, not that chapter because one part already we discussed in a live class. So today we start the topic that is gravitational potential energy. We know that the potential energy, the energy possessed by virtue of the body whenever the body is at rest. So the gravitational potential energy means the whenever the two bodies or the two objects are placed or situated very close to each other, they will interact through the gravitational force. That means they will attract each other by the gravitational force. Due to this force, they possess mutual gravitational potential energy because both are in a rest. According to their position, whatever the energy they possess, that is called the gravitational potential energy. So, how can we find out the potential energy? We know that the energy and work done is related to each other. So, if we find out the work done expression or the value of the work done, that work done is stored as a energy. In case of potential energy, that work done is stored as a potential energy. If it will be the in motion, then the work done is stored as a kinetic energy. So we can define the gravitational potential energy of a body is the energy associated with it due to its position in the gravitational field. Gravitational field as similar to the electric field, magnetic field, the field or the area or the region within which we can experience the force, that is called due to that electric charge, that is called electric field. Due to magnet, that is called magnetic field. And wherever we get the gravitational force, wherever we experience, wherever any object experience the gravitational force, that area is called gravitational field. So due to its position in the gravitational field of another body and is measured by the amount of work done in bringing a body from infinity to a given point in the gravitational field of the other. So we know that we define these things like this way, that the electric potential energy, the work done in bringing a unit positive charge from infinity to that point. Similar way, just the terms are different. The amount of work done in bringing a body from infinity to a given point inside the gravitational field, because within that field or within that area we can not we that object which we bring from infinite, they will experience the force. That's why the given point in the gravitational field of the other. When one body slices the infinity from another body, the gravitational force on it will be zero, because gravitational forces acts whenever the bodies are very close to each other. So if one body is within the gravitational field, another one is a infinity, so the gravitational force between them, it will be zero. So we can also say that the potential energy also be zero, so that is called zero level of potential energy. Now we derive the expression for potential gravitational potential energy. For this, we consider the earth as a uniform sphere of mass capital M and the radius is r. Now we calculate the potential energy of a body of mass m at point P. At a point P. That means the point P, it is lies within the gravitational field. That's why at point P we calculate the potential energy of a body, another body with mass is small m. And we consider the distance from center of the earth, that is OP, that is equals to r, small r. This r always greater than the radius of the earth. So for that we consider more 2 points 8, because we bring that object or that mass m from infinity. So first from infinity to a point, they will that mass will come, then a to b, b to c, c to d, like this way they will that mass will come at point p. Okay, so we consider at any instant of time the body is at point A. So the distance from center of the from the center of the earth, that is OA, equals to x. So the object is lies at a distance x from the center of the earth, whenever it will be come from infinity to point A. So whenever the object is at point A and the earth also be another one object, so a gravitational force is act between them. So the force is according to the law of gravitation, F equals to gmm by r square. So here r square means x square. So this is the expression for force. Now the object move from A to B. Now we consider this the distance between A to B, that is a very small distance. So against this gravitational force, the gravitational force is acted away. It will try to move the object towards the infinity, but the object is moved towards the B point, A to B, against the gravitational force. So it have to do some work from A to B, and if we consider this distance is very small, that is dx, so whatever the work done, they will the work done, small work done in moving the body through that small distance, that is also be a small work done, that is dw equals to w equals to f into s, we know that. So here, because the small work done due to that small displacement, dw equals to f into dx. Now we put the value of f, gmm by x square into dx. So that is for A to B. Now if we consider another one point, that is C. So B to C, that is also very small distance, that is dx. So from B to C, another one small work done, we get expression C to D, another one dx, D to E, another one dx. So up to P, whatever the dx we get, dw we get, all dw if we add together, we get the total work done. So in calculus method, that is called integration. So the total work done in bringing a body from infinity to a point P. So x value is from infinity, its started point is infinity, or initial limit is infinity, and the final point PP is a distance, that is a r. So that will be, we can write like this way, w equals to integration of dw, integration infinity to r, small r, gmm by x square into dx. If we integrate it, we get minus gmm by r. Minus because the work done, this is against the gravitational force, that's why the minus sign, this negative sign indicate the work done or the potential energy is opposite to the gravitational force, and this work done is stored as a gravitational potential energy of the body of mass m. So and the potential energy is denoted by capital U, so U equals to minus gmm by r. This is the expression for potential energy. I hope it is clear to everyone. Now that is a gravitational potential energy. Now what is a gravitational potential? Similar to electric potential energy. Okay. So the electric, mainly the concept is similar, all these things are similar, just definition is different. The gravitational potential we calculate at a particular given point, at a particular point. So infinity to a point inside the gravitational field, if that point we consider A, B, C, so whatever the value we find out, that is with respect to that point. So the gravitational potential at a point is the potential energy associated with a unit mass due to its position in the gravitational field of another body. So gravitational potential at a point in the gravitational field of a body is defined as the amount of work done in bringing a body of unit mass, because in case of a charge, unit positive charge, so unit mass from infinity to that point, in which point we calculate the potential to that point. So potential is denoted by V. V equals to work done per unit mass, W by M. So the unit is, it is a scalar quantity, its unit is joule per kg. SI unit joule per kg, CGS unit erg per gram, and the dimensional formula m0 L square to the power minus 2. Clear? Now the main thing is same, the potential, the we calculate the amount of energy, amount of work done. Okay, but the potential we calculate at a given certain point, that point is fixed, we calculate, or and whatever the mass, unit mass we bringing from the unit infinity to that point only. So whatever the value we get, or whatever the work done we get, that is called gravitational potential. Now gravitational potential at a point due to the earth. So already we know that we get this expression W equals to minus gmm by r, that is a work done bringing from infinity to a point at a distance r from the center of the earth. And from the gravitational potential we get this expression V equals to W by m. So if we put the expression of W in this case, so small m cancel each other, we get minus gm by r. Now at the surface of the earth, that distance, that's capital R, that is equals to the small r. So in place of capital R and small r, we can write capital R, that is a potential at the surface of the earth. So the relation between gravitational potential energy and gravitational potential, what we can write, U equals to minus gmm by r. So minus gm by r into m, that is called minus gm by small r, this is called gravitational potential. So gravitational potential energy, that is equals to gravitational potential into mass. So at that point we find out the gravitational potential, and if we multiply it by mass of that body, we get the potential energy, gravitational potential energy. This is the relationship between these two. Next, this is a very important topic, that is called escape velocity. Escape, you also hear this term. If we throw a ball into the air, if we throw a stone into the air, what happen after this? After some time, it will be returned back to the surface. It will falls back. Okay. So if you have some superpower, and with that power, if you throw that object and it will never back to the earth's surface, that velocity is called escape velocity. So for that we need that amount, that power, that superpower we need. With that velocity, if we throw an object, the body, that they will not return back to the uh, earth's surface, or they will just escape from the gravitational field of the earth. There will be no force act, there will no gravitational force due to the earth, it will not act on that object. That is called escape velocity. So it is a minimum velocity with which a body must be projected vertically upward in order that it may just escape the gravitational field of the earth. That is called escape velocity. It cannot be returned back to the earth's surface. Now, if we want to find out the expression for escape velocity, this is the diagram, same thing. We find out in just opposite to the potential. In potential energy, we consider the object is come from infinity to some point, and from here from earth surface to infinity. Infinity means that is out of the gravitational field. Okay. So we consider the earth is a sphere of mass m and radius is r with center O, and we consider a body is of another body of mass m, it is lies at point P at a distance x from the center. Okay, at a distance s, OP equals to x. So the force, one gravitational force of attraction will act between them. So F equals to gmm by x square. We know this. Now, if the object will move little bit from P to Q, little bit distance, that is dx. So small work done also be done by that object through the small distance dx. So dw equals to f into dx, gmm by x square into dx. So like this way, P to Q, Q to R, R to S, up to infinity they will move. So if we want to calculate the total work done from Earth surface, that means the radius x equals to R to infinity, R to infinity. So W equals to integration of dw integration r to infinity gmm by x square into dx. After solving this, we get gmm by r, just opposite to the potential energy. In potential energy, we get minus gmm by small r, whatever. and here gmm by capital R. This is the work done. Okay. Now, if we consider that v suffix e, this is the escape velocity of the body, then it will be the motion in the body. In whenever you project, it will be in motion, so it will possess a kinetic energy. So that velocity half mv square, that is equals to this work done. That is equals to this work done. So from that, half mv square, that is equals to gmm by r. So v square equals to 2gm by r. So escape velocity ve equals to root under 2gm by r. This is the expression for escape velocity. Now, if you want to express the escape velocity in terms of acceleration due to gravity, so we use this relation. We know this relation between small g and capital G. G equals to gmm by r square. So in place of gm, if we put gr square, we get ve equals to root under 2 into small g into r. 2 into small g into r. This is the escape velocity expression. This is the expression for escape velocity v equals to root under 2g r. Okay. Now, if you consider the mass of the earth, so you can replace by mass, you can put in place of m these things. If you want to represent the escape velocity in terms of density, so you can write this expression 3. Otherwise, maximum time we use either expression 1 and expression 2. Expression 1 in terms of capital G M R, and expression 2 is in terms of small g and capital R. So these are the different types of expression for the escape velocity of a body. Clearly, the escape velocity is not dependent upon the mass of the body which is projected. Now, if we put the values, the small g, capital R, that is the radius of the earth, we get the value of escape velocity, that is 11.2 kilometer per second. 11.2 kilometer per second. That is the value of escape velocity. If you throw a body, that is a minimum value of the velocity. Okay. This is the minimum velocity with which you can throw the object, then it cannot be returned back to its initial position. So if you have any problem, please write in a comment box. Thank you very much.